Whoa, hello there, fellow YouTubers. Welcome to another great episode of Programming on Your Channel, Code Morsels, where we tackle eating the code elephant one bite at a time. Today, I begin the long-awaited series of data structures using C++. Data structures are structured collections of similar data that allow you to organize your code, your data. They enable you to perform optimized searching and processing. This course will begin with the safe array. Future series will cover linked lists, queues, stacks, binary search trees, hash maps, and possibly others. Please remember to click that like button. I would really appreciate it. Also, I will be doing a giveaway once I reach 1,000 subscribers, but in order to find out if you win and to get the instructions, you will have to subscribe to get the instructions of how to do it. Please remember to click the like button. I would really appreciate it. Also, I will be doing a giveaway once I reach 1,000 subscribers. The only way to get the instructions for the giveaway will be to subscribe and have the alerts turned on for the button. So let's get to it. Some languages have a way to detect the length of an array. In some languages, the array even has a length property. C++ does not have that length property, and there's not a standard way of getting the length. So first, we're going to take a look at the normal use of an array. In this code example, you see that we have a function that receives two parameters, the array and the array's length. It then prints the contents of the array to the console. So as you can see here, we get the items and the length. So all we're doing here is printing the array in this for loop. And you can see that we print everything out. And it's normal to pass around the array and the length in C++, but we always end up having to do it. Notice in the code sample that we must always pass the array and the length. That is because arrays in C++ don't know their length. Therefore, to avoid walking off the edge or even to get all the items in the array, we must know the length or size of the array. In other words, we must know how much memory is allocated for the array. So anytime we pass arrays to functions, we must also pass their size or the length. That adds a little bit of overhead. Any overhead in programming should be removed. That is if it becomes repetitious. So avoiding repetition is a good practice in programming overall. Keep the DRY principle in mind. Do not repeat yourself. That is where our safe array comes in. It's considered safe because we always know the length. We will also do some trickery to avoid writing to a section of memory not allocated for the array. And I'll say this about the trickery that we perform in the array. We will write to the end of the array if the index goes past it. Depending on your context, it will be better to throw in an out of bounds exception. A detected in your face exception is usually better than a bug that produces weird results in production. That is because you want your program to fail bad, and hopefully it'll do it early and not in production. And that way, you know there's something wrong. It's going to take a little bit of coding to create our own array. We have to create an entire class. This is C++, and C++ is object-oriented. So let's just pause for a moment. Will you ever have to create your own array in professional environment? Well, probably not. C++ has an array class already in the standard template library, or better known as the standard library. It was formerly known as the standard template library, and it's something that comes with C++, and there's no reason why you shouldn't have it. But since you're learning, it's good to understand how things work and to create your own just so that they know that you know how they work. And then that way you have a better understanding of the language. The purpose of this video is to show you how to create your own. Should you create your own? Like I said, probably not. Our creation is for two purposes: to get a better understanding of data structures and to practice lower level programming, which will make you a better programmer. Our implementation will not be nearly as robust as one that is already prepared for you in the C++ standard library. So whenever possible, use libraries that already exist. But if you ever have to create your own, you'll be equipped to do so. Let's begin by adding the class. So here we have just a basic REPL that we have hello world. So let's make sure that our hello world runs. Let me move the console over. We can see that it runs with hello world. That's good enough for now. Now we need to create a class called safe array. So let's go ahead and add that file. So to begin creating the class, we just need to begin coding. And we need a public section. We know that for our array, we need to have a constructor. And let's create the default constructor, and let's create another. Well, let's just create the one and constructor, and we'll give it a default. So we'll say int size, and we'll give it a default of 10. We also need to add the index operators, since we're going to have that. Back a little bit, and we'll have t template and operator like this. And then we need to have a size operator, so we'll have a size, and that'll just be an integer, and it'll be size. And then let's see what else we need. That's really all we need. We do need to have a destructor at some point. It's just good practice to have a destructor, so we'll create that. And to make our class actually complete, let's go ahead and add the full implementation. Even though we're not doing anything with it, let's go ahead and add it. And one of the problems here that we're going to run into, we may run into a compilation error here because we don't have we're not returning anything. So we should be returning something here, but it's a bit complex to return something that we don't have. So let's go ahead and add the other pieces that we need for the private section. And since we have an array of data, we're going to have an internal array. And we can call that just, for lack of better terms, the array, and we'll have the size. At this point, for this, we can just return 0. And I know that normally with TDD, you actually shouldn't be implementing anything or returning anything, but I like to have something to start off with. There's certain things that we do know up front. And we know we need those two things, the array and that. And in this case, since we have that, let's go ahead and return. Let's just go ahead and return the array. And we'll return whatever index. We'll come back and fix this. This is not going to work right off the bat. So we have that. And let's see the array. This should be a dynamic array. So let's go ahead and make that a dynamic array. And we'll have that. There's a little class that I like to use for my TDD test, and I call it my tester HPP. So let's go ahead and add that. Okay. And I'll just go ahead and bring that in. And like I said, the code will be down in the description. So if you're interested in getting the code for all this, we'll just bring it in. And I'm just going to go ahead and bring this code into it. And this is just a set of assertions, just assertion logic, just to test our code. And it's very simple to use, as you'll see in the main. I like to start off with the failing test. So let's go ahead and add some code to make it fail. And the way we do that is we're going to have to include the tester here. So we'll include tester.hpp. and we'll include safe array. So let's go ahead and create the safe array tester class. So let's go ahead and add that safe array. I have to add it more than once. Okay. And the way we set up that class is we have to bring in the safe array. So that's one of the first things we have to bring, include safe array. And we'll bring in the tester class. And we'll just create a class that has the test in it. So we'll call it class safe array. And it'll inherit from or extend tester. And this is our safe array. Since we did create it as an HPP, we want to also make sure that we use the if not defined directives. So we'll name this safe array test HPP. And then we'll define safe array HPP, and we'll just end our define down here. And I think we did that for the safe array too, but I didn't define. I need to define safe array. There we go. So now that has it. And so let's see. One of the things in the main that we just want this to be able to test everything. So there is a little function that I like to create, and this could probably be best put into the, maybe we can put this function into the HPP. It would probably fit better there. Since we always use it, it might be better, and then we just pass it the tests that we add to the array. So, but let's go ahead and put it in the main for now. Let's put this little function. And all this little function does is run through the test. You can see that it receives a vector of tests. It keeps track of how many passed and how many failed. It runs them. It runs a test. Then the tester class will know how many passed, how many failed. Then we just output that information. One of the things about this is that according to best practices, normally I used to using namespace STD, but apparently that's bad practice. But it does really lead to a lot of writing these namespaces, and it's kind of like one of the, my opinion, one of the bad things about C++. Normally in most other languages, you don't have to do this, and you don't have to do it in C++ either, but it's apparently bad practice not to do that. I think we have everything here, okay? And so now, in order to test the safe array test, we have to add a class of safe array tests. So did we include that safe array? Oh, we don't have. And I think we might not actually need the safe array test.hpp. We might not actually need this. Is that what it's called? Yeah, that's what it's called. And so we'll create the safe array tests. And then all we have to do is push those back onto the test vector. So let me go ahead and do that. And then we just run the test. So we just go ahead and take this and push the test and run the test. And right now we don't have any tests in our safe array tests. We don't have anything here. There are some things that we have to implement in our safe array tests. And one of the things about it is we have to, that we have to add is a run method. Notice that in our tester, there is a virtual, and it should probably be a virtual, pure virtual, but it's not. And so we have to implement this run. So the way we run that pure virtual, we just say void run and then it'll do it. So let's go back to our safe array tests, and we'll have in the public section, it'll be void run. And let's, in order to do any tests in our class, all we have to do is run something, and it will run the test. Now, in order to do that, we'll have to create a test. We'll call it foo. We just want a failing test. And here, since we inherit from tester, it has all the functionality of tester. And all we have to do is say assert. And surprisingly enough, this thing doesn't give you IntelliSense. So let me go ahead and just put something here. So we'll say assert equal 0 and 1. And notice the parameters in tester, if you look at the asserts for it, in tester, there is an assert equal that basically just takes expected, actual, and the test name. And that's all we have to do in our main, in our actual, not main, but in here. And we just give it a failing test. So this, something's getting in the way here. Let me move this. Okay, we'll just test 1. We'll just call it whatever, test 1, or we'll call it foo. Just to make sure something, that everything compiles and it's working and it's running. One of the things about this tester class is that we also have to add, we have to explicitly call the test. And no, this is not normal for tests, but in this case, we'll just call foo, and that runs that test, okay? And we'll just, let's see if this even compiles at this point. Probably not. So let's see. Redefinition of size, and safe array HPP 22. So we have size here. We should probably call this size. Let's see. Yeah, let's call it size. And we're not returning size here yet. We're just returning 0, but it complained because we had the same name for the variable, for the member variable as we had for the function. So let's see. It didn't like that. Let's try it again. Okay, and now we got a failing test. So now you can see that we have we ran one test, it failed, and it tells us that it failed, okay? So now in our, going back to our tester class, everything's in place. So now we have to start writing tests for this. So we want, of course, our test to pass. So we'll just say foo, and it should pass. Okay, so now we have a testing path, which is not really valid, right? But we want to do, what we want to do first is that we want to make sure that our array length is of size, our first test that our array length is the default size of 10. So let's move this out of the way. Should be we'll say another assert equal, and we expect it to be 10. But notice we don't have an array yet, so we need to bring in the safe array. So we do have that. We'll create a private member for safe array. Not safe array test, safe array. We'll just call it array. And one of the things about it is that we are not initializing the array or anything initially. So let's see. We're not initializing the array. Oh, one thing I forgot about the categories is that when there is a categories portion of the safe array test for the tester class. So we do need a constructor for it. So let's go ahead and create that really quickly. Safe array tests. And we'll set the category. Because normally, see what happens is if I run this right now, it tells me if it's only when it fails that it should show me. So let's go ahead and run this real quick. Notice how it tells me, oh, it didn't like that at all. Okay, something's left unimplemented. So it didn't like a lot. What happened? Safe array. Oh, it's just us bringing in the safe array. There's obviously things wrong with our safe array. Safe array test to tester project. Okay. I don't even recognize a lot of these errors, but I know that there's something wrong with the array. So let's keep the array out for now. Let's just keep the array out for now. There's obviously something wrong there. So let's go ahead and run it again. Let's clear this. Let's run it. Okay, so now it's because we have an unfinished test. Let's run it again. Let's clear it. Okay, so it says total test failed. Oh, this is interesting. This is something that I was not expecting. It says test, total test, pass, total test. Total test pass 0. One thing that I forgot to put into this was to actually get the results of the test. So let's go ahead and run it again. Let's bring this back over here so we can see it. And now it should give us the results. There it is. That's what I was looking for. So this get results is what gives us the results of what failed and what it expected and what it was. So that's what I was looking for. So anyway, so that's by adding this to the actual test runner. So now let's get back and see if we can get this to compile with the safe array. So the safe array has some issues right now. Apparently it's not compiling. One of the things about the safe array is that we have to tell it what type of array it is. And we're just going to work with integers. Okay. So now let's see. And now we are actually going to check to see if it's of size 10. And we'll say, what do we call it? Array. Okay, and just go ahead and run it. Bring this over, see if it compiles. And so safe array test failed. Okay, well, one other thing that and like I said, this is not a very robust system because we actually have to explicitly call every test that we run. So go ahead and explicitly call that one. Okay, and now we can see that expected 1 but was 0 and expected 10 but was 0. So we have 2 failing tests. So let's get those tests to pass. So let's go back into here. So this one we know it's just this, and we can actually get rid of that test. But now the size 10, we have to do something about that. Now, according to TDD, the only thing that you should do is make it where now we do enough for it to pass, and that's it, right? So we cheat and we say that our size is 10. So let's go ahead and run it. And we have 2 passing tests. And you say, well, you cheated. Well, that's just the way it is. But we have more tests to run. So another test that we should test for in our code is test to see array size should be 20. And we can copy this. And we'll change this to 20. And what we're going to do is, instead of having the array declared here, we're going to declare an array down here. And we'll just name it my array. But this time, we're going to pass in a size of 20. And it should be size of 20. And when we run it, it's going to fail. Oh, and one thing again, we have to add our test. Should be 20. We have to make sure we add it. Okay. So we know that it expected 20. So how do we fix that? So let's go ahead and take that array, and what we have to do something specific here. And we should say that now our size equals a size equals size, right? And so now, since we return the size, we will return the actual size. And both those tests should now pass. The existing one and the new one should pass. So let's go ahead and run that. And so the test passed. Now we have to create another test that when we assign to the array, should assign to last element. And so in this case, we have an array size of 20, and we want to be able to assign to it. So we can say my array, and then the last element we know is 19. So we can assign, let's just add 19 to it. And we expect it to be 19. And it should be 19. And we should also call it. And when we run it, we have all kinds of funky stuff. And I think it's complaining that instantiation member function, control reaches end of non-void. So let's go take a look and see. Let's fix that, because we are not initializing the array. So one of the things that we have to do now is initialize our array. And so now we should be fine for this. So we have an array of that size and we should be able to assign to that. Okay, so let's go ahead and run it again. Okay, apparently that wasn't enough. Let's see what it says on the errors. Okay, that's obviously something wrong with our operator. Let's see what's wrong with it. And one of the things about the operator, notice that it returns a value. So we assign, and we're not doing anything with it at this point. So what we have to actually do is return the value. And this is a little weird because you notice it doesn't look like we're assigning anything to it. Actually, we're returning the value and it gets assigned to that. Since it's by reference, we actually can assign something to the variable that's in there since it's returning it by reference. And so let's go ahead and give it a try again. And now the test passed. So now we have an array that's actually working, but we have to do some other additional tests. Okay, so one of the things about it is that we have to assign, what if we assign to all the values in the array? So let's take it one step further. And let's go ahead and let's create a smaller array this time. We don't want to go that far. Let's just do 5. And then we can just create a for loop here. And this is the benefit of having the size. And so we can just walk down the array and we can do an assert equal. Actually, before we do the assert, let's go ahead and assign to the array. And we'll just assign the I value. And then we can do another loop. We can do another loop to check the values. And so we could say assert, and we expect I to be that. And we'll say, we'll just say index. Now, in this case, it gets interesting because we may actually want to know which one failed. We'll leave it like this for now because it gets a little trickier to try to concatenate strings in C++. We'll just leave it just like this. But what we're going to do is we're just going to make sure that every one of these tests pass. And it should pass already. We have this. It should pass, but if it doesn't, we'll fix it. So it should assign to every element in the array. It didn't, because I didn't say equal. I just say the search. Let's fix that, let's run it. And it passes. But there's one more thing in the array that we want to do, and that is another thing that we want to do in the array is to see what happens when we assign to the end of it, right? Like past the end. And so let's go ahead and check that. And I think for that one, it'd probably be best to copy this test. Oh, you know what? One thing that we didn't do, it passed those tests, but we didn't actually run it. And again, this is a very bad part of this tester library that we have to explicitly call every test, because normally in most other languages, you don't have to do that. It automatically does it. It's just a poor man's testing implementation, but you should test your code. So it gives you at least that. So let's go ahead and test what happens when you write to the end of the array. And like I said before, it would probably be best if you threw an exception, but in this case, we're going to write to the end. So we'll create an index and we'll write beyond the index. So we'll write to 20 and we'll write the value 20. And we expect 19. We'll expect the value 20 to be stored at 19, which could be a very bad bug if you do it. To assign to we're going to say assign past last element. Assign to last element when past size, something like that. And we'll go ahead and call this go ahead and run it. And it failed, right? And C++ lets you get away with things. It probably did assign somewhere out there, but then it didn't assign like we expected it. So what we have to do when we do this is just take and check the index. And if it's greater than, we'll just assign to the last index. So we'll do something like this. If they're going past the index, we'll just assign it to the last index. So let's run it again, see if it works this time. And this time it passed. Okay. The other thing that we can test, there could be more to this, more tests to this. One thing that we haven't done yet, and we should probably check to see that it destroys everything. One thing that we should probably check to see is that it destroys the memory, that it actually destructor works like it's supposed to. The only thing we really have to do here is when we destroy it, is we just have to say delete the array. And that makes our class complete. Now, is this as robust as something that you would get out of the library? Well, no, probably not. And then some other things come into mind, that what if you needed to pass this array around? Like, what about your copy constructors for the safe array? And what about all those other things? Well, this is just a small demo on us creating a safe array, but it's not totally complete, because you would actually need to have move operations, because you don't necessarily want to do deep copies of all the data that you have in the array. So that's one disadvantage that you have when you create your own. You have to start thinking about things in a more robust way. So You don't necessarily, if you do your copy constructor where it copies every value over, that's a lot of overhead to copy over. So, but anyway, I hope you liked it. Hope you enjoyed it. And like I said, all the code for this will be posted in the description below this video. And the other thing is that hopefully you stick around for the other implementations of classes. So there it is. And oh, one more thing, as far as the giveaway, I'm really considering maybe in your comments, put down what you would like to see for giveaways. Of course, it has to be something within reason. What I have in mind right now is maybe some Amazon gift cards, maybe $150, maybe a couple of them, maybe 3 of them. It just all depends. But right now, yeah, put it in the comments and let me know what you would like to see, if that's good or if maybe there's something better that you have in mind. You know, I will give the instructions as we get further down of how to enter. But one of the requirements is that you will have to be subscribed in order to win. So thanks for watching, and I hope you enjoy.